Hello बच्चों, let's read the question. So the question says a mass A of 0.8 kg moving to the right with a speed of 5 meter per second collides head on with a ball B of 1.2 kg moving in the opposite direction with a speed of 4 meter per second. After the collision, A is moving to the left with a speed of 4 meter per second. Find the velocity of B after the collision and the coefficient of restitution. Okay, so let us first revise the key concept behind this question. So what are the key concepts behind this question? So the first key concept is that whenever there is a system and there is no net external force acting on the system, then the conservation of linear momentum holds. So the first key concept is conservation of linear momentum. So what does conservation of linear momentum say? It says that the net momentum initially of the system denoted by Pi is equal to net momentum of the system finally, and hence the momentum of a system is conserved whenever it undergoes certain changes. Okay, so this is all about conservation of linear momentum. The second key concept which I'm going to tell you is coefficient of restitution. So what is coefficient of restitution? So what it is? So it is the ratio between the relative final velocity to the relative initial velocity. Its formula can be given as E is equal to, it is denoted by E, it is equal to V2 dash minus V1 dash upon V1 minus V2, where V1 dash and V2 dash are final velocities of particle 2 and 1, and V1 and V2 are initial velocities of particle 1 and 2, and its value lies between 0 to 1 for a real case world. Let me write it correctly. So its value lies between 0 to 1 for a real case scenario, and E is 0 for perfectly inelastic and E is equal to 1 for perfectly elastic cases. We can keep them in mind. And keeping these two key concepts in mind, let us check our solution part. So for solution part, what do we have? Solution. So for solution part, we are given that the ball A, let's suppose ball A is moving in this direction with a velocity 5 meter per second, and its mass is given to us as 0.8 kg. So it is 0.8 kgs, and a ball B is moving in this direction with 4 meter per second, and its mass is given to us as 1.2 kgs, and after collision the ball 1 after collision the ball A is moving to left with a speed of 4 meter per second. So after collision we make ball A, it is moving in this direction with 4 meter per second. This was ball A initially, this was ball B, and this is ball A now. Its mass is again 0.8 kg, and the ball B is moving in this direction. Let's suppose we take it V. Okay, so V2 dash, let's suppose, and this is ball B. So now let us find the velocity of ball B. So let us apply conservation of linear momentum, which says that net initial momentum is equal to net final momentum. So the net initial momentum is given by 5, which is mass of first. Let's write its equation first, then we can put the values. So the net initial momentum will be given by m1 v1 plus m2 v2, and the net final momentum will be given by m1 v1 dash plus m2 v2 dash. Okay, so this must be satisfied because conservation of linear momentum is satisfying. So let us write the values, put the values. So m1 is equal to 5. V1 is given to us as, sorry, m1 is given to us as 0.8, and v1 is 5. So we can multiply them still, just the values have been swapped. Okay, so m1 is 0.8 and v1 is 5 meter per second, plus m2 is 1.2 kgs, and v2 in this case is minus 4. Why? Because we are taking this direction as positive. Now again, in the second case, m1 is given to us as 0.8. M1 is 0.8 and its velocity becomes minus 4, because again this direction is taken as positive, plus m2 is again 1.2, sorry, let me write it here, 1.2 kgs. So m2 is again 1.2 kgs. So it is 1.2, and the v2 we don't know. So okay, v2 dash. Now let's find its value. So it is 4 minus 4.8 is equal to minus 3.2 plus 1.2 V2 dash. So let's find it out. It is minus 0.8 is equal to minus 3.2 plus 1.2 V2 dash. From here, V2 dash it is. From here we can find the value of V2 dash. It comes out to be equal to V2 dash is equal to minus 0.8 plus 3.2 over 1.2. So it is equal to 2.4 upon 1.2, which is equal to 2. So V2 comes out to be equal to 2 meter per second. So this is the final value of V2 which was being asked. Find the velocity of V after the collision and the coefficient of restitution. So I have discussed the formula earlier. So coefficient of this restitution is given by V2 dash minus V1 dash over V1 minus V2. So it is equal to 2 minus V1 dash. What is the value of V1 dash? It is minus 4. So it will be minus 4 here. And V1, what is the value of V1? So V1 was 5 and V2 was minus 4. So it is minus 4 and it comes out to be equal to 6 by 9, and hence it is equal to 1 by 3, which is equal to 0.33, which is quite a real life scenario. So coefficient of restitution we have found out. These are two answers. Let's highlight them here. I hope you understood it well. Thank you.